Well, what about that? Good morning, good evening, or good night, depending on wherever you are around the world. It's fantastic to have you here again on our Learn Live TV session today, again on Cosmos DB. This is part of a series. I don't know about you, but I'm super excited. I'm here with my buddy Matt. How are you doing, Matt?
I'm doing very, very well. How are things with you?
Well, you know what? I just actually grabbed a glass of water prior to getting into the broadcast, into the stream, and I just realized that it's snowing outside. So it's actually pretty fun.
Oh, nice. Yeah.
How's the weather at your side?
Quite cold. So Kentucky is normally warmer than this. I think this morning when I woke up, it was 11 Fahrenheit. So a little bit strange for us, but there's no snow or ice on the ground, though there has been most of the last 2 weeks. So I'll take sun and cold.
I have a buddy in Florida who actually just shared a picture on his Facebook tweet earlier today with him shoveling snow. And the quote was along the lines of, Sunshine State, my, well, you know.
Right. Yeah.
It's interesting. And I would actually like to learn from our audience what the weather is like at wherever they are, because we want to make this interactive, right?
Yeah. It's more fun
Awesome.
that way.
Absolutely, absolutely. So today on our Cosmos DB series, we're actually going to talk about a fun topic of mine, which is moving data into and out of Azure Cosmos DB using obviously the SQL API, because that's so close and dear to our hearts, as are the other APIs. But I don't know about you, Matt. SQL API is my favorite API, at least. What about yours?
I mean, having been a DBA, that's what kind of brought me into the world of data. SQL is pretty close to my heart. Yeah.
Even though it's a bit of a lie, isn't it? Because it's obviously no SQL databases and it's not a proper anti-SQL that we all know and love, but it's a fantastic API. I mean,
Yeah, and it looks like it, right? If it looks
it
the
looks like
part,
it.
then a lot of different people with different backgrounds can be comfortable playing with this because you can kind of make it look like whatever you're used to.
100%. Absolutely. Now, for those of you who are first or brand new to our series, who haven't seen or met us before, my name is Alex. I'm going to be your co-host along with Matt here. I'm what I call a Microsoft Regional Director and the Microsoft Most Valuable Professional. But, well, don't be fooled into believing that I work for Microsoft. I'm actually part of these two programs. And I guess that's just maybe a token. Sorry if I'm too arrogant of my enthusiasm and my passion on, well, everything Microsoft and more than that, really. Matt, why don't you introduce yourself?
Yeah, so you can see title, where I work, all that down on the lower right. And yeah, so my background is, I really kind of accidental DBA was my first job in data way longer ago than I'd like to admit to. And
Let's
that
keep that
journey,
as a hush hush.
yes, yeah. And that journey kind of took me into, full-fledged DBA work and then into consulting where you touch a little bit of everything like this, which is why I'm excited to be a part of this because hopefully there are some people here who maybe day to day don't use this or aren't familiar with it. And I'm kind of approaching it from that angle too, is I do use it and I'm excited to share it, but I'm hoping some people came. It's like, well, I see SQL there. I have 90 minutes. Let me go learn more about that because that's not maybe a flavor of SQL or whatever that I know of. And so hopefully for newer folks, something they see here is going to, make them want to play with it more.
But from a very high level perspective, the topic that we're going to cover today is about moving data in and out of Cosmos DB, which can be either a continuous process on one end, right? But on the other hand, it can be a one-shot operation as you're maybe migrating or moving from one account to another, and you want to move some data or maybe use some other technologies, and you want to move in and out of your data in and out of your Cosmos DB account. And this is not something that you would necessarily do regularly, I mean, daily even, but it is something that inevitably you'll come across. So you have the option of, well, going through a long manual and a bunch of articles or whatnot, or just having fun with us here and watch us during our conversation. And obviously, after the fact, get your hands dirty on Microsoft Learn, spin up a VM that is completely for free because it's part of the entire learning experience on Microsoft Learn, and get to test the thing, right?
Yeah, yeah. It's only, I get to drive race cars once in a while and kicking the tires is fun. And kicking the tires on, cool stuff like this is always fun.
Absolutely. Now, there's an entire army of people actually besides ourselves. There's obviously our moderator who we say hi to, Chris Hyde, who will actually answer all the questions that you guys have. And some of these questions will be popped over to us as well. So again, I encourage everyone here to make this interactive. So if you have any questions, I'll be more than happy to take them. And I'm sure Matt does the same, and Chris will do a fantastic job actually trying to answer most of these. And there's more than just the three of us, actually. There's program managers and principal program managers and a bunch of other producers who are all hard at work and who we all salute for actually driving this effort further, so that you guys, whether you're on Twitch, whether you're on Twitter, whether you're on YouTube or Microsoft, most importantly, Microsoft Learn Live, you are actually going to watch this live and get, well, to have fun with us. Brilliant. So actually, the topic today, as we have said, is actually covering this Microsoft Learn module, specifically called Move Data into and out of Azure Cosmos DB. This is what we're going to focus on for the next hour or so. And after we conclude, before we conclude, there's obviously going to be an exercise, at least an exercise. There's going to be a knowledge check. And if you want to follow along, make sure that after the session, not during the session, but after the session, you get your hands dirty and walk through the learn at your own pace. And there's experience points that you're going to get. And also make sure that you tag us on Twitter after you completed your lab. I'll be more than happy to follow up with people. I'm sure, Matt, you will do the same, right?
Yes. Yeah. And those are fun because it is gamified a bit. So we all like getting, XP and unlocking achievements and stuff, right? So yeah, it's nice and light with just kind of the right balance of detail and introduction.
100%. Now, Matt, I have a question for you. Did you get certified on Cosmos DB yet?
I have not, but I suspect we're about to learn how I could do that.
You're right. So there's a brand new certification on Cosmos DB, specifically called the Microsoft Certified Azure Cosmos DB Developer Specialty, which is obviously all about Cosmos DB, the ins and the outs. As far as I know, this just recently came out of beta. Or about to come out of beta. I might be wrong on that one. I haven't taken it myself yet, but I sure will towards probably within a couple of weeks from now. You know how to take an exam? Have you ever taken an exam, Matt?
I have.
I have.
Yeah, it's. I know things have changed a little bit because, to be honest with you, the last exam I took was at an in-person testing center, and that's typically not the way that's done these days.
Definitely not. So today you can actually take the proctored exam, which means that the comfort at your own home or the office or wherever where you have some quiet time, hopefully you can take the exam. And there's a new thing about Microsoft certified exams as well, which is that they do expire, so that we kind of enforce you to stay up on the edge and stay up to date with the content and with your assets. But rather than getting recertified again, you go through a Microsoft Learn knowledge check that is going to take you probably 30 minutes or so, given on the exam that you're trying to recertify or renew. And you can do that whenever you have time, obviously from the comfort of your home, your sofa, wherever have you. And it's, again, going to take you probably 30 minutes or so, and you can do it anytime 6 months prior to the expiration date of the certificate. So that's pretty cool if you ask me, in my book at least. Everything happening on Microsoft Learn, brilliant stuff.
Yeah, and it does kind of fit the pace at which these things move too.
It sure does.
I feel like a lot of this, in Cosmos especially, having a certification and then having it for 3 or 5 years, it changes so much that kind of those quick jumps do make much more sense.
I'm still super nostalgic when I think about Document DB, the former name of the Cosmos DB before it had all the bells and whistles and all the cool features that it has today. A database born in the cloud. That's what I said.
That's right.
So our learning objectives today are actually quite a few. The first thing that we're going to cover is migrating data using some Azure services, and along that path, actually, we're also going to cover Spark and Kafka. In all fairness, this is what we're going to start with, to be fair, and then we're going to focus on the Azure services. Matt, why is that? Why do we start with Spark and Kafka?
Well, because we're going to show a variety of services during this hour-ish, and some, maybe all of these are going to resonate with you, or maybe one, or maybe you're going to get through all of these and say, well, I don't use Synapse. Stream Analytics, cool, I don't use it. Kafka, I'm not really familiar with, but I still want to know how to do this in a way that's kind of a comfortable entry point. So we're actually going to show Azure Data Factory at the end of this. So if you get through all of it and you're like, we don't use any of this at my site, or I don't have budget for it, or whatever, ADF is kind of that good thing where you could either take it into work and use it there, or use it personally as well and use some of the Microsoft Learn exercises. And so you'll walk away with something that's comfortable, we hope, at kind of every level, no matter what your background is.
So actually, just last week, with one of my colleagues in my office, we seeded the database in Cosmos DB using Azure Data Factory, and the experience was just so good, so good. It was so straightforward, and I'm so excited about that part. But that is going to be the last part of our module today. So make sure that you stick for the entire thing, because I guess we saved the best for last. Maybe I don't know. I don't want to spark. I don't want to spark the joy or anything by that, like that. But in my opinion,
it's all
we
cool.
kind of saved the best for last. Cool. So when we think about shortly after you create a new database, right? You have a brand new database, and now you want to maybe learn more about Cosmos DB, but you have an empty canvas, right? Even when you do designing on an empty canvas doesn't really help you much. So after you create the new database, I guess it's not uncommon to migrate some data into that account so that you can, well, tweak the buttons a bit and tune the database and see how it performs, and see if you change the partition key, how that may affect your performance and your database utilization. And there are a bunch of different services which do that. And Matt, you're kind enough to actually already mention 4. Did I count correctly? 4 different methods?
I believe we're showing 4, yes.
Brilliant. And we're actually going to cover all of them today, which I'm super excited for. So Spark options, Kafka options, Stream Analytic options, and Azure Data Factory as another option. So there's a bunch of Azure native as well as open source services that you could literally leverage for the same purpose and the same tool. As they say in the famous proverb, there's multiple ways to skin a cat.
This is very true.
It is very true. So our first topic today is going to, or rather, our topic today is going to start by talking on the Kafka connector. Kafka is one of these buzzwords that many of us have heard, for sure. But it also tends to be that buzzword of a technology that either we know, utilize, and we're a subject matter expert of, or we have heard about it, but we kind of shied away and hid under the table, and we don't exactly know what it is, right? So maybe let's first cover what Kafka is, or Apache Kafka, because it is an open source technology under the Apache umbrella. And one way I would think about Kafka is like this distributed event streaming platform, which is used by thousands of companies around the world for the one purpose of high performance data pipelines, streaming analytics and data ingestion and integration, and also mission critical applications, right? This might sound a bit like marketing, but the reality is that Kafka is like a distributed data store. It means that it is persisted in multiple places, fully optimized for the ingestion and the processing of streaming data. Streaming data meaning like data that moves around, right? And this typically happens in real time. So streaming data is data that would be continuously generated by thousands of different data sources, which typically send data records simultaneously. And such a platform needs to handle this large, constant influx of data, right? And process all the data sequentially and incrementally. So Kafka typically provides the publishing and description to stream of records, does effectively store stream of records in the order in which the records were generated. So there's, to an extent, order guarantee. And it also processes the stream of records in real time. So therefore, Kafka is kind of the primarily used built-in real-time streaming data pipeline and for applications that adapt to data streams and combines messaging, storage, and all of these fun topics under a single umbrella. And it's also actually super utilized. I've just learned earlier today that Kafka is utilized in the manufacturing industry, for example, by 10 out of the 10 companies which are in the manufacturing industry, or 7 out of 10 banks. Similarly, 10 out of 10 insurance companies are using Kafka to an extent, or even 8 out of 10 telco companies are using it. So it is quite popular. And having a way to actually use Kafka to ingest data in Cosmos DB is something that obviously super important. Have you ever done that, Matt?
Well, so it's funny that you mentioned percentages and things like that, because Kafka is something I would hear a lot about, and I'm not consulting now, but when I was, it was almost always part of, if I went anywhere large or even mid-size or even small, it was almost always part of what their architecture was, because we would always sit down and say, tell us about your shop. What do you run? What does it do? Why did you choose these platforms? And Kafka did indeed work its way into a lot of clients that I had. So those percentages do kind of line up.
coming from the same consulting experience, what I believe about Kafka is that it is the kind of technology which democratizes the way we do a particular thing. Like Kubernetes is all about container orchestration, and Kafka is all about the streaming of data, right? The technologies which exist prior to Kafka either were vendor locked in, or they were not very performant, to say the least. And therefore, Kafka kind of created or drove itself into an industry which can leverage the technology to create a bunch of new capabilities for their applications and their systems and whatnot that previously were completely impossible. And having a connector that you would utilize from Kafka or towards Kafka in accordance to Cosmos DB is brilliant. So again, Kafka is an open source stack, right? And you use it to stream events in some sort of a distributed manner. So many companies end up actually using Kafka for large-scale, high-performance data integration services. And Kafka Connect is a particular tool within the suite of stream of data between Kafka and other data systems. And therefore, understandably, this obviously includes Cosmos DB as well. So Kafka Connect is the tool that we're focusing on. In the context of, or in the world of Kafka, the word that you would use for the source of a target or the source or the target of the data, depending on the direction the data moves in, would be referred to as a sink, right? That would be your target. So when you use Kafka Connect for Azure Cosmos DB, things get a bit tricky because you need to go over another tool, which actually happens to be open source as well, available on GitHub, on Microsoft's repository, specifically Microsoft-/Kafka Connect Cosmos DB. And there's a bunch of instructions on how you download and install the jar file manually, and they're all available there. Now, one thing to bear in mind, however, is that this project is, at this time at least, pre-production, right? This is not to say that it's unstable. Quite the contrary, actually. It's super stable, working pretty fine on almost all the time on pretty much any scenario you can think of. But you might still find it super useful to file maybe a feature request or maybe ask a question using the issues feature of GitHub. And you're in direct connection, effectively, with the developers working on the tool, which make Kafka Connect and Cosmos DB and the movement of data towards and out of Cosmos DB possible. Now, also, you may wonder, again, what Kafka Connect is, because I've already briefly said that this is a tool. It is a tool that you normally utilize for scalably and reliably streaming data between Apache Kafka, whatever cluster you'd have running Apache Kafka, and any other system, right? So with this tool, it's just super simple to quickly define what we refer to as connectors, and then you move the large collections of data into and out of Kafka. And Kafka Connect can, simply ingest entire databases or collect metrics, if necessary, from all the application servers into a Kafka topic. And therefore, it just makes the data available for the streaming process with super low latency possible. And an export job that would potentially deliver data from Kafka topics into secondary storage and would also query systems or into use batch systems for offline analysis would be done using the Kafka Connect tool. And the cool thing about Kafka Connect, when you utilize it and when you leverage this GitHub repository and the tools that I was telling you about previously, is that there are some configurations that should be set to properly configure the connectivity between an Azure Cosmos DB and your Kafka cluster. So, and these are obviously super simple and straightforward. So the properties are, as the name suggests, connect Cosmos DB connection endpoint, which effectively refers to the account name or the account endpoint URI specifically in Cosmos DB. Then you have a connect Cosmos master key, which you would set, and this refers to the account key of your Cosmos DB account. You specify the database name, that is obviously the name of the database resource in your Cosmos DB account, and then the topic name that you would utilize from your Kafka cluster, which would utilize a CSV format that would would do a mapping of the Kafka topic to a container straight down to your Cosmos DB account. Now, if you haven't used Cosmos DB account, the concept of a container might be a bit new to you, and we're definitely going to cover that. But what's important to remember here is that each container should normally be mapped to a topic. So, for example, suppose you would like the products container to be mapped to the prod listener topic, and the customers container to the customers listener topic, and so on. In that case, you would use a CSV mapping that would be similar to the one that you see here on the slide, where you specify your topic first, and then a hash sign, and the name of the container that it would be mapped to. And if you have multiple such topics and multiple such containers, obviously you would just separate them by a comma. So it's not super complex, but there are some technicalities and some syntactic sugar, I guess, that you must be aware of. How do you find that, Matt? You're on mute, just FYI.
I am. So yeah, definitely
Always
works
the fun
better
button,
when
right?
I'm off mute. Yeah. One of the things I think that's interesting walking through this is even if you're sitting there and Cosmos is completely new to you, what's interesting is that the kind of the common threads, a lot of Azure stuff that you're going to play with, that concept of a URI and a key and all that is common whether you're doing AI type things, this type of thing. So even if you walk through this and you're like, you know what, Cosmos is not something that I'm going to use, and actually I'm brand new to Azure and just kind of walked into this, seeing these slides, walking through these examples are going to teach you some basic concepts that you'll be able to take elsewhere in Azure services.
100%. Couldn't agree more. Cool. So now that we have that under on the table, let's write some data maybe to an Azure Cosmos DB by supposedly creating a topic. So in Apache Kafka, all the messages by design are always sent through a topic, using a topic, right? And you create a new topic using the Kafka topic CLI command. So for example, if you see here on the left side on the slide, we would create a new topic using that command. Actually, let me zoom in so this makes more sense for people. Use the CLI Kafka topics, and then you just specify the command create, and you specify a bunch of parameters like the zookeeper, the topic, the replication factor, and the partitions. Actually, along the lines of the partition, Chris just told us that there is a question. I don't know exactly where it came from. Maybe it's Twitch. Maybe it's something along those lines, which is how do you address? Can you address how partitions fit into I don't know exactly what this would refer to. Maybe Jason, you can help me out on this one on the question itself. But I trust that here it is. What's the point of Cosmos DB in the Kafka Connect scenario? I missed it because I had PTSD shakes. Hope you're safe. So the point would be just the movement of data. Obviously, when you would utilize Kafka, you would analyze or just move data for a streaming scenario. But maybe you just want to bunch all the raw data in Cosmos DB for further analysis at a later point in time. Or maybe you're getting some telemetry data from IoT sensors around the world, which are just streaming data constantly, maybe counting cars on the highway, or counting some metrics from your sensors on a PMS system, on a property management system or whatnot. And at some later point in time, you want to do machine learning or train a system or get some intelligence out of that. Using the tools for streaming the data out of Kafka and moving it over to a data repository, a sink, wherever that is, helps you achieve that, where you persist the data, because otherwise Kafka doesn't do that, right? Utilizing this in Cosmos DB gives you the additional advantage of being able to take advantage of multi-masters, doing quick queries, doing proper partitioning, and considering your data schema models, utilizing and consuming the data so that you present it in a particular point or in a particular way. So it's all about the movement of data, which is Kafka. And once you have that under the table, then it's all about the processing of the data, the analysis, the further cleans of data, maybe, because IoT generates a bunch of buzz interference as well. So
lots of noise. Yeah.
Lots of noise. Cool. So back to the slide deck on this command that you see here. I know it says bash. It doesn't have to be bash because it's CLI. You can run it anywhere at the end of the day. This command would effectively create your new topic. And once the topic is created, the command that you see on this other slide, which is on my right of the slide, I know I'm zooming in, so it's not really obvious, is a command that you would write actually to start a producer so that you can write records to the inventory topic. Actually, on the next slide, let me bring this one up. I am already writing some events. And this is just a simple basic JSON where I'm specifying that I would enter these 3 records. You would do the same thing, actually. You'd follow the same instructions in the Microsoft Learn module when you go through it. And once this write is done, these records will be committed to Cosmos DB APIs to a container map to the topic products. So again, if you take a couple of steps back, what I did here was to create a topic in Cosmos DB, in Kafka. With the topic created in Kafka, let me go back to that. I created my producer. I specified where that particular producer would be producing the messages from. I've pushed my messages to the producer, and thanks to the connector that is configured, my data actually ends up being pushed over to Azure Cosmos DB. If you think about your data statically, it doesn't make a lot of sense, right? But if you think about your data constantly moving and being ingested and so on and so forth, Kafka makes a lot of sense because now you can decide where exactly the data should sit at. Now, granted, this would not, again, make a lot of sense because you could easily say, why are we not pushing our data directly to Cosmos DB? That is because many times you want to do what is known as time series-based analysis of your data. So, for example, in the example of the highway with the cars under the highway, you are not counting each particular car, but rather you want to understand how many red cars are on the highway right now. And you typically do that by analyzing in a split of 10 seconds how many red cars passed under a particular barrier or something like that, right? So this would give you information that would be updating regularly every 10 seconds probably, or you could do the data slice where each 10 seconds increases by 1 second. So they're overlapping a bit, but you're still going to count, you're doing an aggregate to the count. And that would be an analysis that Kafka does. But if you want to persist that data, then use the connector and persist the data on a persistency layer on a data storage system, such as Cosmos DB. It can also be other systems if you want to. Cool. And then when you want to read data from Cosmos DB, similarly, and then maybe move it over to Kafka for analysis purposes. Maybe you have an e-commerce website and your orders or your profiles or your whatever else is going to be pushed over to Cosmos DB. That data can also be read out of Cosmos DB using the container and pushed over to Kafka using Kafka Connect. So you can create a source connector in Kafka Connect using a JSON configuration object. The complex JSON you see here on the slide deck right now is one of these configurations. We don't want you to learn this by heart, by all means. But the cool thing about this configuration is that, in fact, most of these properties are going to be left unchanged, believe it or not. So as you walk through these configuration properties, you're actually only going to do a change to 4 of these. And there are some configuration settings that you probably want to change, right? So the connection endpoint, the master key, the database name, the container topic name. These are things that you definitely want to change. So just for the purpose of the illustration, we could potentially specify for the endpoint a value such as the URI right here, the master key, whatever, base64-like looking key, but it's not a base64. Then you have a database name, then you have a topic name, and that's about it. And once you have that, you have configured your connector, and you can also read from Cosmos DB, which enables a lot of different scenarios where you're utilizing Kafka, or you already have Kafka built in your systems. How do you like that, Matt?
Yeah, cool and fairly easy. So when you put it like that, and you're looking at it's like, code is a little bit scary, but it isn't really. And I will say, if you're looking at this and you're like, oh boy, well, that I get that, but Kafka, I don't really know what some of those words means, and I don't know that tool. I just want to get in the portal and play with it. At the end, we're going to do just that. We'll do, like I said, kind of an exercise that everybody can walk through, where you don't have to remember any of these keys and things like that. Though, as you said, it's not like you have to memorize them now. We can copy and paste things.
We sure can. And again, that one tool that we're going to look at towards the end, Matt, you're going to probably show that to us, and we're going to run a fantastic demo. I'm sure about that. Data Factory specifically.
Yes.
Is a tool that you could easily leverage even for like a one-shot operation where you just want to move some data in and that's it. Whereas here with the streaming of data, the expectation is that you're going to have some continuous data being pushed over to Azure Cosmos DB. So sometimes this is not very useful. Using the Kafka connector is not very useful if you just want to do a seed up of a database, of a Cosmos DB database account.
Right.
There are other options.
I would say that, kind of like you said, this is good if you have a mature-ish IoT setup and you're looking for somewhere to kind of store that data and do more analysis on it than you're able to now. I know I can think back to a couple consulting clients I had where they got really excited and found budget for IoT sensors and all of those sorts of things and had that set up, and it was amazing. And the very cool nerd stuff, and they're like, all right, well, we have all this data. Where should we put it so we can do stuff with it? And then that was often when we would get involved and you talk about Cosmos or other services, and it is kind of built for that, and its flexibility is going to be helpful there, because you don't, especially if maybe different IoT projects happened, but they're all supposed to be the same thing. Sometimes different information is sent back to the database and all that. So it helps to have something with the flexibility like this has, so you can go through that data and do the work to make it worthwhile. Gathering it's one thing, analyzing is why we store it.
You know what they say about data these days. It's the new gold, right? So we definitely want to retain that data and analyze it further, and then whatever else, do analysis, run train models, and do machine learning on top of that, whatever have you, so that we do predictive analysis maybe of those IoT sensors,
right?
In terms of, I don't know, metrics on temperature or humidity or whatnot, and understand if something is about to go wrong before it actually happens, right?
Yeah.
That's why
and especially now, something like that can be a huge advantage. So if you're doing predictive analytics against, let's say, your fleet of trucks or something like that, if you can predict a failure and prevent that failure, the supply chain in some cases is already quite stretched. So that gives you a leg up over maybe another company who's not doing that, who now has to take a truck out of the fleet for a few days to do a fix that was going to happen years as well, but you caught it before it happened and fixed it.
So, hey, Matt, we have a question actually from Shanawaz on YouTube, which goes along the lines of, I'm curious about having only single container that can hold various types of entities partitioned by row type column. What's your suggestion on this? Please suggest.
I'm going to give the classic SQL data answer. It depends.
Isn't that always the IT consultant answer anyway?
Because it always does. But yeah, it's funny if you go through some of the learning path stuff and some of these examples, you'll see some things set up like that. But I've seen plenty of cases where it's not set up like that, and it's funny because the world that I come from, normalization means obviously what it means here. It's there's different concepts at play. Alex, you can correct me if I'm wrong here. I don't know that there's one right answer to this, because I think it depends on the data you're storing and how you're going to query and use that data, pulling it back out. So for me, it's not like you should always do it this way, because I could see both sides here, and the examples kind of look like that too.
So I think there are two folds to answer this question. One fold is you can pre-provision your throughput per container, right? Or you can pre-provision your throughput per database and share that throughput across all the containers you have. And then if you think about your container as an isolation layer per customer, because you may be running like a multi-tenant application, then you want to have your throughput per container, and think about the way you do your data modeling specifically on the partitions themselves, rather than having multiple containers running in parallel. And that row type is effectively a typical design pattern where you're creating the partitions based on the row type. And that's a very okay way to go. But that also implies that every time you're querying or writing for data, that row type is well known, and every single query will contain that, so that you only run the query against a single partition. And similarly, it also suggests that the row type is containing enough values to actually at some point create physical partitions, because otherwise, which means probably even millions of entries or documents in your container, because otherwise you would, well, honestly shoot yourself in the foot, because you can end up creating hundreds of thousands of the different row types, and this implies that you're not leveraging the actual physical partitions. Because remember, the partition key you're setting is just like an indication it's a logical partition, right? It's just an indication towards the Cosmos DB account on how physical partitioning should happen in case you have a lot of data. But if you don't have a lot of data, and if your partition key is chosen incorrectly, you're kind of stuck with it, right? So you have to create a new container, start to use maybe Data Factory to move your data from one place to another, apply some changes to it, and so on. Hopefully this gives a better answer to your question, Shanawaz.
And this could also have an impact on cost as well, right? Because the decision you make there, the amount you're pulling, the RUs you're asking for, kind of, it does seem like it could have an impact there.
Yeah, absolutely. I mean,
which
if
is
you choose your
important.
data
Yeah.
model wrong, or if you choose to pre-provision your throughput and you're using the incorrect model there, as in per container / per database, or not using an auto scale, if you have like spikes in your utilization, this can exponentially increase your cost. Definitely. If since we're at the topic of real-time data ingestion and real-time stream of data analysis and processing, obviously you're going to have a lot of spikes, right? Because your data is continuously coming in, but at some point you might have a larger batch of data coming in. And having autoscale, which is not a feature of Cosmos DB, is something that works out pretty nicely many times, especially when you have spikes, right? Cool. Now there's another question actually on Twitch from Fuelsnable, and sorry if I'm mispronouncing and butchering your name. I really hate when I do that. Who asks about the Avro schema in Kafka with Cosmos DB. So the answer to this one is actually straightforward and a bit more elaborate at the same time. Yes, you can use Avro, but there's a bunch of supported data formats when you use the Kafka Connect application. Specifically, you use just plain JSON, as you have seen me previously highlight in the slide deck. You can use JSON with schema, which means that your connector and your application is aware of the actual data schema and structure, and everything just is according to a single schema, or Avro. Avro is another format that became pretty popular over the last couple of years, which is row-oriented with remote procedure call and data serialization frameworks, which again was obviously developed within the Apache's Hadoop project. What was it, a decade ago, I guess? Something like that. But
feels like it, yeah.
Cool. So now another technology that you can leverage, which actually follows along the same lines of Kafka, is Stream Analytics. This is an Azure service, isn't it? And it still goes along the lines of real-time event processing. Stream Analytics is actually one of these engines which was initially designated and designed to process fast streaming data from multiple sources simultaneously. And you might argue, hey, wait, isn't this the same thing as Kafka? Well, to an extent, conceptually it is, right? It can aggregate, it can analyze, it can transform, and even move data around to other data stores for more profound and further analysis. And, if I do take a couple of steps back again, I just realized maybe I didn't do enough of a good job explaining real-time eventing or sometimes streaming processing. This entire thing about real-time stream processing is about consuming messages from either queue or file-based storage processes. Then we have the processes of the message, the processing of the message, and then the forwarding happening to another message queue, another database, another file store. And this literally happens in real time because it scales out, it parallelizes the actual processing operation, it slices the data into whatever slices, time-based, window-based, you name it. And then the processing itself that I'm referring to can be just a simple query or a filtering or an aggregation of the message. There is a typical so-called Lambda architecture when you do these kind of things, where you have like a hot path and a cool path. And imagine you have an IoT scenario, and then you push all of the telemetry data that you're gathering from your IoT sensors. But every now and then, one of the temperature sensors can indicate a extremely high temperature. So on that path, that hot path, you would have a filter which says, if our temperature is above 100 degrees Fahrenheit, we should fire an alert. And then you integrate Stream Analytics with another system, and then start sending text messages maybe, or push notification messages, or you name it, whatever works, right? Again, why do we have so many tech and so many different pieces of tools? I guess
because they're fun.
Again,
that's why.
There are multiple ways it's going to get.
Yeah.
And sure enough, in Azure, there are numerous options actually to choose from when it comes to picking a technology, even for real-time processing.
Right.
In fact, there are several data stores that you could leverage. I can think of Apache Kafka, of course, and Azure Stream Analytics, but even HD Insights has the Spark streaming capability and feature. Or you could use Azure Functions, right, Matt? You could also use Azure Functions for doing this, or simply web jobs on an app service.
Right.
And I'm sure I've probably forgotten a few.
Well, and what's funny, so you mentioned Azure Functions in that context, but something you just said made me think of another use for it. And so, so we've talked about kind of how you're storing this data in real time, how you're analyzing it, how you might want to flag something and say, if the temperature is over this threshold, then do something. You could use Azure Functions to kick that off if that thing is a message to a maintenance person or something like that, or Azure Logic Apps, which could kick off an entire workflow, connect to a number of other services, based on the alert we've kind of talked about here. There are a lot of intersections in the way these services can be used, and even like with functions, the first thing that comes to mind, you could use it twice in that diagram, just kind of two different parts.
Absolutely. And they really appreciate the fact that there's something for everyone, right? You
Yeah.
may be a data analyst, you may be a data engineer, you may be a data scientist. One of these technologies is not a technology that you might feel comfortable with, right? It goes outside your comfort zone. You might be a data analyst typically using Spark, right? No problem. There's a Spark connector for you, right? So you get some Cosmos DB, and the other individual gets some Cosmos DB, and everyone gets some Cosmos. Cool. So when you think about the configuration of a streaming analytics, it all really falls down to configuring your output sinks, and you can configure multiple output sinks, and these include your Cosmos DB SQL API. Now, one thing that must be noted here is that, again, as of right now, only the SQL API is supported as a output sink for your Cosmos DB. So no MongoDB API, no Cassandra API, no Gremlin API, or Table API for that matter, because we have a lot of APIs in Cosmos DB. But sure enough, I can only speculate that at some point in time, those are going to come as well. But SQL API it is for now. So configuring the Azure Cosmos DB SQL API output consists of either selecting the account within the subscription or just providing the credentials, and this obviously refers to the account identifier, the account key, the database, and the container name that you want to push your data to, or read the data from, rather. And then you would have a bunch of query results from Stream Analytics. And honestly, if you have used Stream Analytics before, you probably know that within the experience of the Azure portal, you just do maybe up to 5 clicks, and that's it. So it's that simple, really. So we're not even going to do a demo on that, because anyone who hasn't even ever used Stream Analytics is probably going to have a very easy time configuring it and getting it to work. Which brings us to the third connector and the third option, the third tech, right?
It is.
Namely Spark. So what do we know about Spark, Matt?
Well, so I like this part because there's likely people here that that have used Spark. I would say outside of the Microsoft universe, and so what we're going to talk about here is how it can link with Synapse to, like it says, you get this cloud native, hybrid transactional and analytical processing, HTAP. So this is kind of, like I said, if you've only used Spark, you've never used Azure at all, this is going to be kind of the section for you, because you'll get to see that interplay with some of these services.
And that's, I think, one of the beautiful things with Spark, which is, again, another open source technology, is that it is not rooted at Microsoft. It is not vendor locking you in, and there's so many different ways to run a Spark cluster, even on Azure. Right. So we are talking here about Azure Synapse. If you've lived under a rock for the past year or so, this is like a rebrand and more, like a rebrand plus of Azure SQL Data Warehouse back in the day, which was only running a SQL engine back then, right? But for doing massive parallel processing of your data and your data crunching and so on. But along came a Spark engine. So if you still want to get that full managed experience with the feel right at home, if you're a Microsoft-centric SQL developer experience, but you want to test out Spark, you can leverage Azure Synapse. But the one Spark connector for Azure Cosmos DB actually works on any Spark cluster. It doesn't have to be on Azure Synapse. It can be on Azure running on Azure Databricks with a Spark cluster, or it can be on a Spark cluster running on virtual machines, or it can be a Spark cluster running somewhere else, or maybe running on HD sites. There's so many different flavors, right? And that's the beauty of it, again.
Yeah, and you can use it really at, like you said, whatever layer you approach this from. Let's say you want to build your own and do that, you can. You can use Databricks. There's whatever background if you're familiar with Spark, whatever your background you're bringing to this, you can use it.
That's the beautiful thing with Spark and also with the connector and Cosmos DB. If we are to refer to, say, Azure Synapse Analytics and Azure Synapse Link for Azure Cosmos DB, what you are doing is that you're creating this cloud-native hybrid transactional and analytical processing to run analytics that would be on your Spark cluster and do OLTP on your Azure Cosmos DB SQL database API. So you effectively have the same data that you're moving in and out of your Cosmos DB, and then you start crunching and doing analytical processes and workloads, and maybe you run your Jupyter notebooks or whatever have you on the Spark cluster, and your data is right there, just like honestly at your tip of your fingers. And that's the beautiful thing with it, because normally you wouldn't necessarily think of Cosmos DB as necessarily an OLAP, an analytical processing engine. But by having the ability of moving that data really quickly over to a Spark cluster, which is by design made for analytics, well, we're doing a bit of a game changer here, right?
Right. Well, and how many scenarios have you seen that are absolutely clean one way or the other, where it's like, well, we want this data, but we only want really the OLAP view of it, or we want this data, but we only want the transactional view of it. There's so many use cases, especially the more data we have on more things, for kind of a hybrid approach, because you're going to have some people that want to see that one view because that fits their role, and some people that want to see that other view or serve it to an application or something like that because it fits that aim better.
This reminds me that in almost every single application I've ever developed, literally, reporting was always regarded as the most important feature. And we always go to the drawing board and ask our customers, okay, so in terms of reporting, what kind of reports do you want? And the first answer we get is a shoulder up, right? We don't know, but reports are the most important one. And the reality is that even if they knew, those reports they were talking about, the requirements themselves change so often, right? So having an analytical workload to do analytics, and even having some sort of a engine or a dashboard on top of that, which helps you aggregate and better understand your data, it becomes essential for anyone who is interested in business insights, right?
Right.
Or business intelligence.
Yeah. Well,
So,
and for me, it kind of makes for an interesting sidebar here a bit, is because I've been in a lot of those meetings too, where it's like, well, which reports are the most important? Well, all of them. Well, of all of them, which are the ones you use the most? Well, we use them all. And right, what it often came down to is they existed. They probably were used once upon a time, but that the environment or the job role or whatever evolved from needing it, and so it still exists. There's, they could still go look at it, but they didn't. And right, what they really needed is something that kind of worked with them. It's like, well, this is what we want to look at now, but 60, 90 days from now, that's going to change.
100%.
But the report never goes away.
Yeah. So when you're setting up the Synapse link, again, remember, everything is cloud native. It's honestly as easy as just first making sure that you have an account. So Azure Cosmos DB create is part of the Azure CLI set of commands that would create a Cosmos DB account. You throw in a bunch of parameter values, such as what is the name of the Cosmos DB account and which resource group do you want to create it, and whether or not you want to enable, this is only a flag, enabling the analytical storage, and you provide a Boolean value of true. And once you have that, and by the way, you can also use PowerShell if that's your thing. Good for you then. After you do that, when you're creating a container, you just have to enable the analytical storage at the container level or on a per container basis. Again, this can be accomplished in a number of different ways. You could simply say AZ Cosmos DB SQL container create, and then along the same lines, you would specify the analytical storage TTL and obviously other parameters as well, such as the throughput, the partition key path, and whatnot. And again, you could also do this through PowerShell. Over here, we have this PowerShell example on creating your Cosmos DB account using the new AZ Cosmos DB account commandlet. Again, what I love here is that everything is that simple. Like, it's even simpler than with Kafka or Stream Analytics, maybe. You can do it programmatically through the CLI, through PowerShell. You just run a single command, and voila, it's done. Now, there are two options to query data from Azure Cosmos DB when you are utilizing a SQL API. And first, you can choose to load to a Spark data frame where the metadata is cached. And this example that you would see over here, actually, uses Python to load a Spark data frame that points to an Azure Cosmos DB SQL API. So what you do here is that you have your products data frame variable, and you simply would use a Spark read format. You would specify the Cosmos OLAP as the format itself that you would leverage for this one. You provide in a bunch of options, and honestly, that's pretty much it. Now, alternatively, you could also decide that you want to create a Spark table that points to an Azure Cosmos DB SQL API directly. And when you run the Spark SQL query against the Spark table without actually impacting the underlying store, you're just consuming a bunch of RUs, and that's it. The example, again, that you would do this can be found on your Microsoft Learn module, and it would be a Python example, but you could do this in so many different ways, obviously. Now, if you want to write data to a new Azure Cosmos DB account, and you do this for your Spark data frame, then you could use this script right here to actually append data in a data frame to an existing container. Again, along the typical same lines, you would have a data frame that you would write, and you'd specify the format to be your Cosmos DB OLTP. See how we use the previous words generically? Now they actually make more sense, probably and hopefully. And then we can even take this further and stream the data from a data frame, starting from a checkpoint. And we can also append the streaming data to an existing container. And there is actually a fantastic example on this one. But in the interest of time, I actually want to get to what we have said. We've saved the best for last.
I hope so. Yeah. So if you've looked at all of this and say, well, I would like to kind of learn more about this. Maybe this is the first module you've seen, and you're like, well, this sounds cool. I want to play with it, but I'm not sure. I've never been exposed to the services I just heard about, or I don't feel like I know enough to kind of dive in and play now. My hope is that we're kind of wrapping up with something that you're going to walk away from and say, well, I just happened to see that. I think it's interesting. I want to go learn more about it and kind of get, hands-on with it. And that's what we're going to do here. So if you're not familiar with what Azure Data Factory is, it says on the on the slide that it's a native service to extract data, transform, and load it across sinks and stores in an entirely serverless fashion. There are computers behind the scenes doing this stuff. I understand the marketing push that it's serverless and there's flexibility there, and I get all of that. But there is a computer somewhere doing this stuff.
Matt, a while ago, Jeff Holland, aka Mr. Serverless, actually posted the picture from one of the campuses, which I guess was going under renovation or something, and there was a large 42-unit rack, completely empty. And the caption of the picture said something along the lines of, "This is our serverless data center."
Yes, exactly. Yeah, I was fortunate enough to do a video for Channel 9. I believe it was last year. The last 2 years are kind of one big year. But yeah, we talked about Azure SQL Database serverless, and they did allow me to say on there pretty much the same thing I just said. Like, there are computers doing this. It's just flexible in how it uses them and pulls them in and out. But yeah, I suspect those serverless data centers have an awful lot of servers in them.
They sure do.
Just a guess. Yeah. Okay. So that's, like I said, the 30-second crash course on what ADF is. If you've done any ETL work and you've thought about taking it to the cloud, you've likely stumbled across this, maybe used it. If not, hopefully as we close with this kind of hands-on lab, you'll see that it's not too bad to use at all. But let's talk about how we would set it up before we get into the GUI, because the exercise, with the exception of some cut and paste, it's going to be all Azure Portal and ADF Studio. So, but in case you don't want to do that, you can set it up as a link service, you can set Cosmos, the SQL API, set it up as a link service within ADF. There's an example on the slide after this where you can see the JSON, what that actually looks like. And yeah, so it's quite simple. Like I always say, a lot of JSON is human readable-ish, better than XML for sure. So we've got a name here, and then properties are pretty simple, right? Type Cosmos DB, obviously, and then connection string, which makes sense. So if you're coming purely from like a SQL Server background or something, connection string looks a little different, but it comes back to, we've got this endpoint, we've got a key, and we've got a database. So again, pretty straightforward there. And going back to the slide right before that, sorry to make this a little bit harder on you, Jason. You can use service principals and managed identities as well. So what I'm going to show, again, is fairly straightforward, and what I hope is kind of a takeaway for you to say, well, I want to go explore more about this. There is enterprise robustness to this, though. What I'm going to show is I'm creating some stuff. I cut and paste an endpoint and a key. If you're like, well, that's great, but that doesn't really fit with the way we provision everything else. Do not worry. You can do it the way you're doing many other things in Azure now. So let's quickly go over how we can read and write, and then hopefully these slides will kind of hit home once we get to the hands-on part. So when we want to read data from Cosmos, it makes sense, right, that we have to configure our link service as a source. And so what does the JSON look like when we do this? So obviously it's going to be an item type of source, and then the type is Cosmos DB SQL API source, and then the query is just kind of an example there. I want to go read something, and then your preferred regions there, as we've talked about, this data can live across regions. There's multi-writes and things like that, and that's kind of a nod to that. What we're going to see in the example isn't quite that fancy, but the possibility does exist. Now, if we want to write to it, similarly, that's going to be a sync. And you define the sync and say, all right, I want to write to this there, and the type of behavior you're going to do. Are we going to upsert, insert, whatever. Now, again, we're not going to see any of this during the exercise because that's going to be a layer down from what we're looking at. But if you've seen all this and you're like, there's a lot of JSON on these slides and I don't really feel like messing with all that, then hopefully the exercise is for you. And
well, I must say, I really do appreciate the simplicity here. I mean, even when it comes to reading the data, when you read from a Cosmos DB account, what do you expect to do? Run a query, right? So there's your query, there's your type, there's the number, the preferred regions, and that's it. And then you write to it, you just specify, hey, here's my sync. I mean, how much simpler can it get?
Well, I think I'm about to show you because the next part is all pictures.
Oh, even better.
Yeah. Okay. All right. So what we're going to do here is fairly simple. I'm going to show you. So if this is the first episode in this series you've seen a lot of references to products and stuff like that, and you're like, well, that seems to be a data set that's pretty consistent through these, but I have no idea how to create that, and I don't know how to populate that. I'm going to show that because, that's kind of an important thing. If we want to read and write some data, it helps to have some, right? So we're going to do that. And then just kind of show how you can use ADF as a pretty simple go-between in this case, from Cosmos and back. But hopefully you're kind of walking away from that. It's like, well, I've seen how I can configure my sync. I know there are other options out there, and I'm maybe not going to go Cosmos to Cosmos, but I want this data to live somewhere else in some other service. If you follow along with me here, you're going to kind of see how that's done. And again, it's pretty easy. Even I can do it. So with that,
you know what? You want to find a store set? One set?
I do not.
Enough talking. Show me the code.
Let's get to it. Okay. All right. So what I will do is I will get to the screen share here, and let's see. Okay, so it is playing nice. And what I'm gonna do is, apologies, it's actually not playing nice. It has signed me out. That's what you get when you kind of pre-bake this stuff, right? Sometimes it's like, aha, I know when you're going to switch to me, and I'm going to make that very difficult for you to actually do. So,
man, we can help you type in your password if necessary, but we got to see your screen first.
Indeed, and we're doing that right now. All right, so hopefully you can see that. And we've got the portal up, so hopefully everybody can see everything here.
Yeah.
All right.
Cool.
Excellent. Excellent. Very good. All right. And we'll get it. And just kind of let me know in the chat. I think this looks good. And so we're going to kind of go with that here. So yeah, what we're going to do is we're going to create a Cosmos DB from scratch. So we've talked about all the different ways to kind of talk to it and all of that. I'm going to actually walk you through what that looks like. So we're going to create that resource here. I find sometimes the search can be a little funny. If you try to be too detailed, you may not get exactly what you want. And so we're going to go to Azure Cosmos DB by typing in Cosmos DB. And much like it, and hopefully if you're here, you're familiar with the portal. If not, the experience here is very similar to just about anything else. You find your type, you click this button here, and now we're presented with options. So obviously, since SQL API is in the title of our session here and what we've talked about, we're going to do that one.
I do appreciate that the portal already teaches. I mean, if you have never heard of Gremlin or Cassandra, there's already a bit of a highlight on how you utilize these APIs and what they're good for and whatnot. And
right.
Getting a reminder that Cosmos DB talks these APIs, aka understands and utilizes whatever application you want to connect Cosmos DB to, or the other way around, with these APIs, just works out of the box.
Right. Yeah, and it's very helpful. And also an encouragement to spend a little money. You don't have to spend any money to do what I'm showing you here, but if you really get into this, obviously Microsoft would prefer for you to do just that.
But
so
as a quick reminder, on Microsoft Learn, people just click one button, which is Start Lab, and they already get a pre-baked virtual machine and an Azure subscription and whatnot. So they don't actually have to worry about any of these, right?
Right. And so, yeah, if you do want to follow along with this as you get to the end of the module, right, you can launch that lab there, and you don't have to provision any of this. And in fact,
they don't need a credit card, they don't need an Azure subscription, nothing. Not everything is free, everything is gratis, everything is whatever word you want to use.
Correct. Yes. Okay. So what I've done here, again, pretty straightforward. Pick a subscription. If you're doing this on a personal sub, that's fine. And in the actual exercise, you may skip a couple of these steps, but I'm going to walk you through the same way because I figure a lot of people are probably going to take this and play with this in maybe a work Azure sub. So subscription, resource group, you must give it an account name. Obviously, it's going to validate that over here. You give it whatever location suits you, wherever you're joining us from. Provision throughput here, we talked about what the benefits of serverless can be with bursty workloads and things like that. We're going to keep this simple. We're going to stick with a lot of the defaults here because we're just going to kind of go play, right? So we do all that, and we go to review and create. And again, this is going to take roughly about two minutes. It usually doesn't take this long. And if it decides to be in a very bad mood, we actually have one. I provisioned one just in case. It's always like the TV food show. It's like, well, we're going to show you every last step, and we're going to put it in the oven, and that's the one we're going to take out. But in case the power goes out, or it sets on fire, we're going to direct your attention away from that, and we're going to show you the one that actually works. So again, yeah, when I've run this, it actually takes about a minute. And of course, now it's probably going to take a little bit longer because we're all here watching it, and the watch pot never
Matt,
boils,
did you
right?
sacrifice any production virtual machines in favor of the demo gods? Because that's what I usually do, and sometimes works. When I'm in favor of the gods, I'm good.
Yeah, no, I've run this over and over again, and I have wood to knock on here. It generally runs smoothly. Like I said, if not, I have one left over from my final run through that we can pretty easily switch to. But I did kind of want to show everybody this experience as well. So once we go through this, what I'm going to do, and it kind of ties back to some of what we saw earlier, I'm going to go to the keys pane. So once the resource deploys, which if the resource can hear me should be any second now, I'm going to go to that pane, and we're going to pull the URI or endpoint as you saw it on some of those slides, and we're going to pull the key value as well, more or less a password. I'm going to copy and paste it into a document Obviously, though that's not super secure, but for our purposes, it will do just fine. So we're going to go to the resource, which took almost 3 minutes, longer than it ever had before. So that was fantastic. So we're going to go to keys here, and I'm going to show you what I was just talking about there. So thinking back, if you were looking at the slide where we talked about connection strings, that's basically what we're building here. And so I'm going to copy this here because we're going to need it here in a few steps, and put it in my super secret text document on my other screen so nobody can see it. This will all go away right after this as well. And then I'm going to pull the primary key field. So if you've used, like I said, any of the cognitive services stuff, a lot of stuff has this notion of an endpoint and a key, and it's basically go over there, use this key to unlock it, and then you can use this service. So if you're sitting here and you're like, well, this was cool, but I'm never going to use Cosmos again, you can take that knowledge away, and you'll know how to connect to a lot of things in Azure. There's a lot of times a keys or an access blade to kind of do just that. So, all right, so I have that super secret information. So we're going to step away from this, and we're going to go to Visual Studio Code. And so we've got this, and we'll go here. And then what I'm going to do is so actually, I'm going to pause here. So obviously this was kind of pre-staged as we prep for this. We're running through things over and over again to make sure the experience is as smooth as we can make it. But one thing I'm not going to show, because I can't show it, is that there is a Cosmic Works tool that basically you run from within code, downloads the package, installs it. What that easy for me to say, Cosmic Works tool does is it will pre-populate that products data set that you saw referred to throughout some of those slides. It's going to give us some information to work with, so I don't have to go into the Data Explorer and kind of hand key stuff or copy and paste it from a site or a document or something like that. So if you don't have that, the string that you would run here is .NET tool install --global, so it's available to every user. Cosmic Works, and then it takes about a minute, and then you can do the other thing that I'm about to show you. And so what we're going to do here is this. So I will copy the example because I kind of like the way it puts this together, and it means you don't have to watch me type anymore in a demo, and I do that every time. The less you watch me type in a demo, the better, right? So we've got here, so Cosmic Works, it's already installed. We're going to run this tool. Then it's -- endpoint, and then the Cosmos endpoint. And on the last one, we pulled that. So again, that looked very much like a URL, right? So we're going to go over this, and we're going to paste the endpoint in. And then we're going to do the same thing to the key as well, which again, if you're kind of brand new to all this stuff, the key is pretty much just the password. And then the data set we're going to populate, because that's kind of how the demo is built, is the product database. And the key makes this command look very ugly. That's why I kind of like to paste it in clean, because you can see what it looks like. Because once I drop the key here, it kind of pushes it off the screen, and it's not as clean, right? So we'll do this. It'll run. Like I said, this took less than a minute every time I ran it. So right now it'll probably take 2. It showed me up. It was seconds. Excellent. Okay, so what that has done is all we did was we created an account before. That created us a database, a container, and items as well. And that's everything we need to kind of do the next bit, right? So now we don't actually need code anymore. So we're going to go back to the Azure portal, and I'm going to select the right program to do just that. And okay, so we're back to the portal. We're here. So we left off at keys, right? So now we're actually going to go to our Cosmos resource, which helpfully is up top because we just made it. And we're going to go to the Data Explorer pane. All right, so I've got data here, which is good. So we're going to expand. So this is the database node. So the database is called Cosmic Works. And then we're going to expand the container node, which is this level, and that's products. And then here we're going to look at items. And I just kind of want to show you an example. It's not particularly attractive, but yeah, we've got some items here. ID, category name, SKU, name, description, kind of all the item stuff you'd expect to see, and then some things under the covers for Cosmos to do what it does. One thing I am going to do here, so we get to scale and settings, and it's going to play nice. Okay, so this is set to 4,000 RUs right now. The exercise you're going to walk through is going to recommend to set this to 400. So I wanted to show you how to do it. Alex, would you like to explain why I should do this?
Well, every single thing that you pay for is consumption based, right? So the higher the RU, you can think, if you haven't used this term before, like the horsepower of your machine, right? But the workload of the database, the more horsepower, the more performant, the more gas you consume, the more expensive it is, right? That's how I think of it anyway. And therefore, 400 would be cheaper.
Yeah, so what you'll see here, so as the values change, and I really, really like this actually. So it says, all right, you set me at 4,000, and hourly, daily, monthly, it's going to cost this. As I change it, it says, the updated cost is actually this. So you can see, as your RUs change, you can see the impact right there. You don't have to guess. You know how much your bill is going to change here. All right, so we've got this. We'll click the save button here because saving money is always good. And it should take just a second or two. And then what we're going to do here is we're going to create a new container because we need a target for our Azure Data Factory stuff. So it's going to pull it out of what we've just seen here. And we need somewhere for it to go. So we're going to create another container for it to do just that. And so what we're going to do here is we're going to go over to, and I'll close this tab because it does clean up the interface a little bit. And we're going to go, oh my goodness, all right, new container. And you can see you can also create a new database there as well. So we obviously want to use an existing, so helpful dropdown gives us Cosmic Works there. We're going to use an ID, and again, just to kind of follow along with the exercise here, I'm trying to stick with kind of what it's going to guide you through. And so that's going to be flat products. It's just kind of a different view of these items. We're going to create a partition key here, and that's going to be on category. You can see it kind of auto completes that for you. Our throughput, we're going to turn off auto scale, and we're going to go to manual because that kind of aligns with what we've just done. We're going to set the RUs to 400. We've got
one thing, Matt,
yeah,
that might be new for people is, okay, we have explained the RU as being the horsepower, right? But how much horsepower do you consume on your database, right? That might be a question. What is an actual RU? Because request unit, okay, cool, we get that. It's an abbreviation or an acronym. But the way people should think about an RU is that this is kind of the cost to do a point read, like fetching a single item by its identifier, which doesn't utilize any additional indexes, and knowing the partition key value, right? So everything is optimal from that perspective. So if you do that for a document, for a single item, which is of 1 kilobyte, that consumes 1 request unit. So the larger the documents, or the more compute workload the underlying database engine has to consume to get that data, to query the information, the higher the RU consumption, and therefore the more RU you would require. And that's why we were saying earlier that data modeling is such a big thing for Cosmos DB, because if you don't model your data correctly, aka you don't know your partition keys, you are not thoroughly sharding your data into multiple partitions by leveraging those partition keys, the more RUs you will consume. So one might argue that Cosmos DB is super expensive, but the reality is that you might not have invested enough time into doing data modeling properly in Cosmos DB, and therefore minimize the RU consumption.
Right. Yeah. Kind of tying it back to a lot of my background. When you're in the cloud and you're pulling data out, so you're paying that data egress charge. If you do a select star from a giant SQL Server table. That's going to be very expensive. If you do a query that targets kind of exactly what you want, it's going to be much less expensive.
100%.
And so yeah, so the way it was described to me once, if you're coming from kind of like a hardware background or something, is that our user really kind of the IOPS of this. It's like, how much work do I have to do? What all am I pulling together to provide this to you? And right, the more precise you are in what you ask for, the less that's going to cost, right?
With the caveat that the IOPS is also incurring for CPU and
Yes.
storage and a bunch more. Yeah, cool.
Yeah, true. Right, so we're going to go down to OK. One thing I did want to highlight here is you saw where one of the slides mentioned Azure Synapse Link, and we saw some of the ways to use code to kind of turn that on. There's also a way to do it here. So there is a GUI method kind of if you scroll down to the bottom. I'm not going to do that here. So like I said, we're trying to keep this focused on kind of some of the basics we can do here. So we're going to do this. It's going to give us the nice little 3 dots here for a few seconds. And then we're going to go to we're going to kind of go back to Data Explorer, and we should see a flat products container, and we do right on cue. Well done, Azure. Okay, so we've got flat products here. So now we're at the point where we're going to create an Azure Data Factory resource to kind of do all this. And again, I'm going to create this from scratch. It usually doesn't take too long, because I want to show you kind of what you'll be doing. If this gives me any trouble, we'll flip to one that already exists. So I type in Data Factory. Obviously, this comes to here. We've got our create button, which we're probably all accustomed to by this point in time. Similarly, if you're a little bit new to this, pick your subscription, your resource group, your region. I provisioned the one thing in West US, so we'll just kind of stick with that, even though Kentucky is more East US. We're going to give it a name, and we're going to call it Learn Live Demo ADF. And we're going to stick with V2 there as well. So one thing, and it did not like my name, so we're going to click Configure Get Later. The exercise is going to walk you through that, so I wanted you to see that here. And right, I fall victim to this every time. A lot of resources allow underscores, a lot allow hyphens, very few allow both. So this should pass the validation steps right here. And so we've passed our validation, we're ongoing. We're looking at this, and yeah, so what we're going to do after this, if you're not familiar with Azure Data Factory at all, there's an Azure Data Factory Studio, and that's going to be our next step here. And what it gives us is kind of a pretty friendly view. Again, like I said, there's going to pretty much be no code here. It gives us a pretty friendly view of what we've got. So let's see. That's interesting. So yeah, okay.
Maybe want to hit that refresh button.
Yeah, that's it had already done it once. Yeah, there we go. Okay, very good. All right, so we've got that, and again, we're going to open the studio. We could read the documentation if we want, but right now we don't have time for that. So we're going to open
about time for our audience here.
Yes,
I do appreciate how we are actually taking it literally from scratch. Like nothing is pre-baked. You see how the cake is done. You see all the not only the icing, but you see every single layer there.
Well, it's one of those things. If somebody hadn't seen earlier ones in the series or something like that, they might think, "Oh, this is cool," but I don't know how to do this, right? So, okay.
Well, can we do this in like 5 minutes? Let's see.
We can.
How difficult is it?
All right, so we're going to go to ingest. We're going to go to built-in copy task. We're copying from the one container to the other. We're only going to run this once because it's an example. So we're going to go to next. All right, we're going to pick a source type of Cosmos DB, which we'll see right here, SQL API. Obviously, you notice the Mongo API is an option here. And we're going to create a new connection. And again, I'm going to kind of walk you through what the example is likely going to want. And we're at least going to fill in the required values. So our authentication method is going to be a key. We've got connection string here as well. And so again, this is all pretty easy, right? So I've picked my sub, and I've picked what I know I created for this, Learn Live MG2. We've got a database. We've got CosmicWorks right there. and we're going to create that connection here. And it's going to take a few seconds. Wow, probably less than one. And so we've got that here. And so we're going to use a query. So we're not going to use this view. We're going to use a query, and we're going to bring that over. So you see, it gives you some examples. So if you're not, I guess, realizing that this is SQL, it gives you that very basic kind of structure, like, select something from something else. So we've got that pulled in here. We're going to select a table. And so we're going to select products because that was the first one we made. That's what we loaded from Visual Studio Code. And we're going to preview data just to kind of show ourselves that it worked. So we see some things there, right? So far, so good. And then we're going to next. So we're going to select the target. And again, very similar to what we just saw. SQL API connection. We're going to use the connection we built in the last one. And so we're going to in the target. So the source is the custom query we just saw. The target is going to be flat product. So it's just a slightly different view of what the CosmicWorks tool inserted. So we're going to go to next. And we're going to call this, we'll just, for time purposes, kind of stick with this name. We're going to leave everything default. And there are kind of helpful tooltips if you want to know more about what that is. And then we're going to go to next. And so we've got this here, and my daughter's just walked in the office. Impeccable timing. So we're going to click next. We can watch this go. And we're going to kind of watch the steps go here. We're going to see green check marks because Azure's in a good mood and it's going to be nice to me. And indeed, it has been. And so we have one last step left. So we're going to go back to Data Explorer. So back to this other view. We're actually going to go back to Cosmos, of course. And so we're there, Data Explorer. And just to prove that a thing happened, that the thing I said happened, we're going to browse. Yes, we're going to browse to this. We're going to browse to flat products. We're going to go to new SQL query up here. I don't love the way the real estate's laid out here, but you can. The thing I do like is you can kind of follow the steps you've made, but I need about a 50-inch screen to have it look the way I want to, right? And so we've done that. We've executed it. Creating items, successfully fetched one item. There we go. So just to kind of quickly go through what we did, we took products. We used the CosmicWorks tool within Visual Studio Code to populate database container items after we had created the account through the portal. We then created a flat products container in Data Explorer here, and then we used Azure Data Factory to take the items from the products thing that the tool built us to flat products, which we built ourselves.
I do appreciate it. It took us, 15 minutes to actually explain the thing. It took Azure probably in total 5-ish minutes to spin up the Cosmos DB, seed it with some data, provision the Azure Data Factory, and probably less than a minute to actually move the data.
Yeah,
so that was pretty darn impressive.
Yeah, and so when you get to the end of the module for today's session, don't let that lab scare you off. We pretty much just did it. So if you're like, oh man, I don't want to spend an hour doing a lab, I already watched these guys for 75 minutes. The lab is pretty much that, and it's really not too bad at all.
So we are on the last few minutes of our live stream today, and I already know I will miss you, Matt. But before you leave, let's maybe do a very quick knowledge check, and then we'll wrap up. So let's test our knowledge. And by the way, the audience can follow along. Oh wait, you know what? I guess I need to screen share first, right? Okay, there we go. It should be coming up any second. So once you see the slides and once you see the questions, also make sure that, this goes for the audience, you can also join in and answer these questions yourself. There's an interactive poll that you can answer. And the first question is, which type of component in Azure Data Factory will you load out to an Azure Cosmos DB SQL API after it was transformed? A is the sink, B is the source, or C, is it an input? I feel like this is a very terminology-specific question.
It is, but I'm going to get everybody's answers, and for anybody who misses it, I'm going to be sad because we just went over this. I will not. There is no grade. But yes, I would say this one's a little tool specific.
This is a bit tool specific, so it's on the terminology side.
Yeah.
So we already have the questions coming up. People can vote. They can start pushing their votes in. We have 100% of people actually saying that it's
The right answer.
Think, and it is the right answer. That's sure enough. Woohoo! Great. So let's bring up the second question then, which goes along the lines of, after enabling Synapse Link at the Azure Cosmos DB SQL API account level, what should you do before you use the Spark connector with a specific container? This might one put a bit to the work. So A, is it install the Apache Spark in Azure Cosmos DB SQL API? B, no further action is necessary after enabling Synapse Link. Or C, enabling the analytical storage TTL at the per container level. Now, just a hint for people, there was actually a configuration I had in my JSON previously when we did the presentation, and it was, sure enough, well, our voters are actually answering this one correctly already. Some of them are. The right answer is actually for this one, C. It is enabling the analytical storage TTL at the per container level. We have covered quite a few today, haven't we, Matt?
Yeah. There was a lot of ground covered here.
We have actually talked about all of the various Azure services that one can leverage to move data around, and also a bunch of different open source services that you could leverage, including obviously Spark and Kafka. So in total, I think we have had, again, if I did count correctly, 4 different ways in which you can move data in and out of Azure Cosmos DB. And in my opinion, I don't know about you guys, but my favorite one still sticks and still is Data Factory. But obviously it comes down to the scenario. So if people want to vote what their favorite method mechanism is, or just leave a comment or follow up on Twitter after the fact, that would be great.
Yeah. Point is, this is all fun to play with, and there's a lot of scenarios where you would need any of the 4 things we went through. The answer, as always, is it depends, right?
It depends.
Yeah.
And the reality is that there's also more things that you can learn for. That's why it depends, right? And you can obviously learn more about copying and transforming data in Azure Cosmos DB by using Data Factory, or using the Kafka Connect tool or the Azure Cosmos DB tool. And the QR code that you see here, or the URL link that you see on the slide deck right now on the screen, will actually take you to all of these fun resources. Also, I encourage people to make sure that they will not miss our next module on the series, because remember, this is an 8 series, and out of the next episode on our Cosmos DB will actually be about, are you ready? Using the Azure Cosmos DB SQL API SDK. That's going to be a fun conversation to have, I guess.
There's a theme here.
There is a theme, for sure. Now, Matt, you did say that you're going to get certified. Are you promising that you're going to get certified?
As an old boss of mine used to say, when I would say, when are you going to do this? He would say, February.
That's good enough for me. That's only in a few days from now, actually.
It is.
And probably so will I. Okay, cool. This was fun today. Any last words?
This was fun. I hope everybody got something out of it and realizes no matter where you're coming from, you can play with this stuff and then use it for real.
I couldn't have said it any better. Okay, until next time, everyone. Thank you for joining us, and let's make sure that we keep the conversation going.
Yeah, thank you.